Okay, let's go ahead and take a look at 11.2 written homework problems. The first question here is we're comparing for 6 participants how they react, right, to different stimulus. And in this case, you have a blue screen in reaction time and then a red screen reaction time to see if somehow the color affects those same people. That's why it's a matched paired. We're looking at those individuals. Again, you have answers down here you could read. What we do want to do is actually run the test to determine if there is a difference in reaction time, right, at the alpha 0.01 level. And so in order to do that, you run a hypothesis test. And if we were doing it by hand, what we're doing is comparing the differences between those and finding the average difference, right, between each of those participants, their scores, not the average of the overall. And so if you did some hand calculations, see these are the individual differences for each participant, and then the average would be the average of those values there. And so the hypothesis test we're running is that the difference between for the participants is 0, meaning there is no difference between blue and red, versus that there is a difference, right? That it's not equal to 0, meaning there is some difference between blue and red. And again, we use the p-value approach. This is if we were doing it by hand and calculating, but we're going to do stat crunch. I'll show you what we have here. So you have the blue and red, and then we're going to do t-stats. In this case, the matched paired. You have the blue, and then you have the red, and we're calculating again the difference between the blue and the red. We could store the differences, you can see them, but and then run the hypothesis test that the difference equals 0, that there is no difference between blue and red for the participants versus there is a difference. You compute, you see you get a p-value, a test statistic there, and this number is bigger than the alpha of 0.01. So in that case, again, we would conclude there's not sufficient evidence at that level to support the claim there's a difference in reaction time, since we're not going to reject the null hypothesis because it's so do not reject, and so you have that conclusion there. You're also asked to do a confidence interval, a 99% confidence interval, to interpret that. So we go back to stat crunch here and edit, and we put 0.99 here, confidence interval 0.99, and we're looking again to see if there's a difference between them. Notice these numbers here. You get from negative 0.19 to 0, so we're 99% confident the difference between these two groups is somewhere between here, negative number and a positive, which means since it contains 0, that it's potential there is no difference. That's why we fail to reject. The confidence interval contains 0, so that's why we fail to reject the null hypothesis. Since the confidence interval contains 0, right, it's possible that the mean difference equals 0. Do not reject this. And so that's what you would be we'd be looking at. It's saying draw a box plot. That's just visual evidence of part C. And since in this case, notice when you run this here, you can store the differences when you run it and compute it, right? Oops, my bad. They're over here actually. They got stored over here. So these are the differences between for those over here. I've done it 3 times. And if you did a box plot of those, you'll see that the box plot includes 0 also. The differences, you'll see here, there's 0. The box plot contains 0, so that's why it's another visual evidence there that do not reject the null hypothesis. We have another question here looking at SUV versus car in terms of is the SUV safer, right? And does it get less damage and cost less? So you can see here some information from cars moving 10 miles per hour. And see who gets more damage in those accidents, who would cost more. So you have those values. It's matched up because you're comparing these types of cars with each other here and the costs. And so what we want to do is run a hypothesis test and then look at the difference of data to see if there's a difference in cost. But you don't have to do that by hand. You can put that into stat crunch. Let me clean this out right here. There we go. And so SUV and car. So again, t-stats paired. One, we could run a hypothesis test just to double check to see is there a difference. in cost between the SUV and the car. You compute, and notice it's a low p-value 0.03. So there's a good chance, right? Oh, we wanted to see if it was less than to compute the repair cost for the car is higher. Okay, so that means looking at that, we want to run that this is the car is smaller than, right? So there we go. And so you compute that right there. Again, that comes from our null hypothesis there. And alternative, compute that. Then we could do that. There's your p-value, small p-value there. And so we can see that there's a good chance, since the p-value is small, we will reject the null hypothesis. All right, in this case, that they're equal to each other. And so looking at that data again, you can see because the p-value is small. Again, the differences are always made here too, since that was done here. If we ran that and wanted to do a 95%, because alpha is 0.05, you can see doesn't contain 0, so that's why we reject the null hypothesis. And since you have those differences again too, you can box plot of those differences, and you can see, let's make that horizontal, you can see that you can see though that contains 0 there, and so there could be there's most of the values are to the left, and so that's again some visual evidence here that potentially they have a lower cost. There's more to the left of 0.